Jason, what can you tell me about a hydrodynamic seal? How do they work?
So hydrodynamic sealing technology, or liftoff sealing technology, has been around for decades. They're used in basic industrial applications. What's really special about what we do is we've really kind of taken that basic liftoff seal technology and really advanced the state of the art in a variety of different ways. And now what we have is a sealing solution that we can employ for critical sealing applications where a contacting seal wouldn't necessarily be an option, and that could be for a variety of reasons, including the desire to have a longer life seal. It could be a high vibration environment. There's a lot of applications where a contacting seal just won't meet the customer's needs. So the liftoff seal in basic function implies that the rotor, the rotating component, will actually separate itself from the stationary component, which is typically the carbon sealing element. Right. And in doing that, we reduce heat, friction, extend life, etc.
Yeah, I imagine that our customers really appreciate that technology, so they don't have to do much less maintenance on the aircraft or whatever the application ends up being.
Yeah, absolutely. These seals offer longer life, which does help with extended maintenance. They also have been proven to really solve a lot of problems that our customers have had in the field. So in some cases, customers have employed a contacting seal that maybe passed qualification in a very kind of basic rig test environment, only to find out later that the vibe levels on wing are higher than anticipated. The seal's not lasting very long. There's also been a lot of cases where our customers have employed other types of hydrodynamic liftoff seals from other vendors and discovered all kinds of latent failures. So we've been able to step in many cases and offer a solution to replace either a contacting seal or in many cases actually replace other liftoff seals that just aren't up to the task,
right.
if you will.
That's interesting. It sounds like great technology. So can you tell me more about how they create that separation, how they actually work?
Yeah, so to get those two surfaces to separate from one another, we actually are creating a pumping action, and we're doing that by putting what we would call our hydrodynamic or liftoff features in the rotor typically. And those are literally, we are putting geometric features into the rotor face so that when the rotor is spinning against the stator, or in this case the seal, we're actually creating a high pressure film of air that will actually lift those two surfaces away from one another.
Yeah, so you mentioned earlier that the technology's been around for a long time. I think it comes from more of the industrial market. How are we applying it in aerospace, and what makes our product different?
There's quite a few things that we do different than some of the other solutions that are on the market. For one, on the rotor side, we have a couple different geometries that we employ for those grooves that we mentioned before. Those grooves are really kind of key to creating that pumping action, which again creates a film of air that'll keep those two surfaces separated. And so we have a couple different geometries that we use. We also have a couple different manufacturing methods that we use. We have some proprietary software that we use both to generate those geometries and also to do kind of the predictive performance analysis. And really what's important there is to create a film of air that is stiff, if you will, and remain stiff throughout the operating condition. What you don't want is to have a seal that works at kind of nominal ambient conditions, but then when it goes up in altitude, loses that film stiffness, because then the rotor and the stator will come crashing back together. And we've seen that in many applications in the field, and that causes tremendous challenges for our customers. The other thing that we do that's kind of unique to us is some of the things we do on the seal side of the system. So we offer a few different types of seals. In particular, we do edge-welded metal Bellows seals, and that alone is kind of a critical art and science, if you will, within our company. We have decades of pedigree on the metal Bellows side, and some of the things that we're able to do there, again, ensure that as the seal goes up in altitude and runs through its different operating conditions, that force balance equation stays intact. If you design and build a bellows that either leaks or can't handle changes in stroke, you actually will affect the force that's being pushed against the sealing element. Right. So there's some things that we do there that are very unique. Really, I think one of the things that sets us apart more than anything is, again, that we can employ these different methodologies, manufacturing methodologies, design methodologies, to really kind of meet the critical requirements for our customers' applications. What we're not doing is kind of offering a one-size-fits-all solution.
So yeah, that's a lot of good information. It sounds like you really have a lot of tools and a lot of ability to customize the seal design to meet these critical application requirements.
Yeah, we really do. You know, our goal is to offer an optimized solution, not a one-size-fits-all solution. And again, it's really important These are not off-the-shelf products. These are, engineered solutions where we're
Right.
really trying to solve critical sealing problems. And so it's really important that we understand our customers' applications, we understand the system requirements, and that we employ the most optimal solution. And again, when it comes to hydrodynamic liftoff seal, we have a lot of pedigree and history, as well as different types of tools at our disposal that allow us to offer an optimized solution.
Yeah, that's great.
Well, thank you all very much. We appreciate you watching.